Well, hello, Engineering 203. I wanted to talk to you about experiment number 4 and experiment number 5. As far as submittals go, they will be two separate labs occurring over 2 weeks. So you'll submit lab number 4, and then the following week you'll submit lab number 5. But as far as technically, they're actually, they build on each other. So your task with lab number 4, or experiment number 4, is to simulate a square wave, and I've got this laid out here. If this is a little bit blurry to see on the video, you'll also be getting a hard or a PDF, a link to a PDF of this. So if it's a little blurry on the video, that's okay. You should have access to a PDF of this. And your task is to simulate a square wave that goes from -1 volt to +1 volt and has a frequency of 150 hertz. And you have a variety of tools at your disposal. You can do a program, you can do a spreadsheet, you can use MATLAB. I've listed BASIC and VBA. Remember, you can get VBA through Excel. If you're, those of you that are doing programming classes, if you want to use a different language, C, C++, Java, something like that, that's fine too. But you want to build this tool, and that's the purpose of laboratory number 4. This isn't a very difficult assignment. I think I've even got some demonstrations for you that you could go in and grab the Excel or the MATLAB and do this with it, and that's fine. And if you want to use someone else's work, just make sure that you give them credit, note where you got that from. But the biggest thing is to build a tool that you can then modify for lab number 5. So before you just grab something someone else has done, make sure that you know what's going on. Make sure that you can modify that in the future. So that's laboratory number 4, and then that's going to take us into laboratory number 5. So here's a picture of an oscilloscope trace, and you can see here this square wave. It's yellow, although the colors are probably not going to show up real well in the camera, but that's what you're trying to simulate. And you're going to try and figure out how many harmonics. Do you need 100? Do you need 1,000? Granted, the computer makes it pretty easy, but there's no need to use 10,000 if you can use 100 and get a pretty good simulation. So your task is to figure out some of those things. And then when we go to laboratory number 5, what we're going to be doing, and this is very much like the exam, question number 2 on the second exam, is we now take this square wave and we input it to our filter, and we wonder what's coming out. Okay. First thing you might want to do is try and figure out, is this a low pass filter, high pass filter, which harmonics is it going to be passing? And then you're going to do an analysis very similar to what you did on the second question of the exam, and you're going to try and model what's coming out of this. And normally we'd have this set up, the circuit set up. You've got the circuit here. Here's a picture of the circuit. You've got your resistor, and we used a couple of inductors in series to increase the value of the capacitor. So we've got the input signal over here, we've got the output signal over there. Pretty straightforward in that regard. Probably the biggest thing that you need to see is a picture of the trace. Okay, so rather than trying to film a oscilloscope, I've just got a picture here, and this is the input wave right there, and it's about 1 volt here, and then -1 volt there, roughly. You can see that there. And then there's your output wave, and it's a little hard to see. It's going to be it looks like it's triangular, it looks like that's straight, but it has a little bit of curve, and I think when you simulate it, you'll see that curve a little better. It's a little more of a sawtooth wave. And this is a little bit blown out of proportion here. You can see that we're comparing 1 volt to 100 millivolts. So this blue one here, this output, is going to be much smaller in magnitude, and is actually it's actually only about 1/10 of that. So don't let the difference in scales deceive you. When you analyze it, it's going to be much smaller, and then you may choose with your analysis to magnify it. So that is then your task with experiment number 5, is to take what you've learned in experiment number 4 to then change your expressions. So now you can not only model what's going in, but also model what's going out. And then write that up. Make sure that you submit your program that you used, the work that you did, and also the output. You use the executive summary approach like you've been doing. That's been working out well. And that then will wrap up Lab 5 and wrap up our experiments for the term. So I think that's it. If you have any questions, shoot me an email. I've been talking with a lot of you. I guess we put talking there, say that rather loosely. A lot of people will send me a question, and I will print it out and write on it, and take a picture and send it back to them, and hopefully that's effective. I think it's worked for some people. So if you do have a question, don't hesitate. Get a hold of me. Shoot me an email. We can talk about it. People call. That's fine too. So as you work on Labs 4 and 5, one thing to be careful of, I will mention before I wrap up here, is I think Lab 5, if you look at it, would be due the same day as the final. So you may not want to have those coincide. So you may want to wrap up 5 a little bit early, which is probably very doable, because once you get 4 done, 5 should follow pretty easily if you've built a proper tool with 4. So that's why I talked about 4 and 5 together, and I will send this your way and turn you loose on this. Take care.